So the mechanical principles, again, just going back over and over again, you got to keep that energy through the middle of the material. So what I'm actually going to do in this video is, instead of using the wrench with the handle on it, I'm going to use just a crescent wrench, and that hopefully will improve my chances of ruining this thing. I hope that I get a bit of a corkscrew. Now, getting a bend in it is one thing, that's a relatively easy fix, but getting a corkscrew in there and really knackering it up, that's pretty good. Alright, so, got all of this thing. Oh, that started well, didn't it? And you can see if I kind of just keep going around like this, put my body weight into it. Oh yeah, that's a good one. Oh yeah.
That hurt my soul a little bit.
I know. It's very difficult to do that. I spent years trying to perfect that skill set. And I know this is it seems like a silly one. Twisting, it's like, oh yeah, it's pretty easy. But I seem to remember back when I was trying to twist up a whole bunch of pieces for architectural work, that it was a lot harder than it should be. It was as though the steel, its sole purpose was to completely and utterly do exactly what I didn't want it to do. Just like that, look at that. It's beautiful.
Probably.
I haven't done a twist that bad in years.
Probably has to do with, over the years learning the appropriate muscle groups to use to keep that vertical axis.
Yeah.
And also building the strength in those muscles to be able to control that it takes some effort, because even 5/8 material, once it starts cooling down, it really doesn't want to go anywhere.
Yeah, that's true. So I work with a gent called Michael Dillon, who does beautiful sculptural work as well as architectural work, and he and Chris Graper developed this really cool rig that locked into the vise. I'm trying to remember exactly what it was. Basically, it had a base plate that locked into the vise somewhere down here, and there was a pass-through, and you could move the top and bottom plates up and down so that you could position the twist on the bar, right? So if this is your bar through the middle, it had a plate here which is locked into the main body, and then it had another plate here which had your handles on it, and this was held together, and this was basically a bearing surface. So it was actually indexed in there. I can't remember off the top of my head how it was done. But what it allowed you to do was come up, drop the bar in. It always went down to the same bottom, so there was a bottom plate in there of some kind, or a bottom stop. And this was locked in, and this distance was always the same. And because it had 4 handles on it, so there was another handle there, and this was locked into center, as you twisted it, it just made the perfect twist every single time. And the other thing, I don't know if you can actually see this on here, Jess, if you will come on in. I have this stop here. This is an adjustable stop, and that was also for the same deal. It allowed me to come down to here. I could drop the material into the vise, align up the stop, so the first portion of my stop was always in the same place. So, little things like that make your life easy. If you are doing, I would say, more than a dozen, go ahead and jig it up, make your life easy. It's not worth it. Okay, so back to endeavors at hand. So, big wiggly thing. That'd be really cool if it was really long and tapered. I'm going to just come down this one side first, just running a flat. And I'm just plodding down that surface. Flip it 180, same again. Have a quick look, it's got a soft bend in it, so I knock that out. That's give or take straight. Look at that axis, back up this way, running down one side. It doesn't matter which side it is, just pick one. I generally go for the one with the most curve, put it upwards. That way the anvil surface or the bearing surface is taking most of the impact in forming. Alright. So I'm going to focus on that front portion. Get that in order. I'm just trying to look at those two axes. Looks pretty good that way. Looks fair that way. Might have to throw a little water on this stump at this rate. Smoking myself out. Have a look here. Straightening twist is an interesting one also, because your eye sees the dimensional difference between this and this as a deformation. Just trying to find visually that center line is, that's a little bit of a pain all in all. Alright, so remember I was telling you about after you straighten, sometimes you find things that they're not true anymore. So my twist is ever so slightly out. I'm just going to give that a wee bit more of a yank. To square it up. Oh, there we go. Give and take. You get the principle of it. You know, it's not super perfect, but general principle of how to get that mess in order.
I think that it very well shows how you should not twist.
Oh, another thing. Have a look at this. Because of that unevenness in the twist, it's kind of interesting. If you come out, so you move out of axis and you're twisting around here, you're actually twisting this, not this. And that's why I have somewhat of a looseness in the top end. Okay? So the twist is stacking down here and here where it was wider out. I came in at the end and kind of brought it back into true, but by that time it cooled, so you're not getting that evenness of twist throughout the bar. Anywho. Yeah, I mean that's the basics of it. Go and twist a bunch of things and go and straighten a bunch of things, and you're going to learn a whole lot about your personal mechanics. Also getting a vise, notice how low that vise is. It's nice and low so I can really get a hold of it, work it in the right place.
What is that, about 2.5 feet off the ground?
28 inches.
Yeah, 2 feet or so.
Yeah. You could probably go lower. This is also nice. I've got a plate down here. You can actually pass through and hit the plate underneath as a stop. You can put shims in there, or you can put a movable block if you need to move the material up and down. I often reference into the center on the throat of the vise itself, so down in this portion, and you know, just make your life easy. Build mechanics. Another one, if you want a really quick down and dirty way to set your distance for twisting, get a piece of pipe. Throw a piece of steel pipe on there, the correct length that you want. You lock it in the vise, drop the pipe on it, put the wrench on top of the pipe, round you go. It will help eliminate some problems. The only problem with that is you don't get to see the twist as it's forming. So if you are doing anything weird, you're kind of stuck with it. Oh, a big one that people seem to think happens is as you twist that the material shrinks. It doesn't. Maybe it does, minutely, but in the scheme of things, from what I've figured out, big long length, maybe you'll adjust it a 1/16 of an inch. And if you lift up, it doesn't make it longer. You are not that strong, I'm sorry. Okay? Go give it a whirl. Try it out in all types of material sections, shapes, lengths, widths, heating it different ways. Oxyacetylene torches are magical, especially for spot heating. So maybe I'll get into some of that on the Patreon stuff. All right? Go have fun.